Hello and welcome to the video on logical deduction. Hi, I am Ravi Handa and this is my Twitter handle. You can use that to connect with me and provide feedback. To begin with, the first thing that I like to tell you is before watching this video, I think you should watch the video on syllogism. Once you understand the video on syllogism, maybe this particular video would make a little more sense to you. In this video, however, we'll talk about primarily the law of detachment and the law of syllogism. We'll also do some solved examples on it. To begin with, let us first look at what exactly is law of detachment. Let's say you are given a conditional statement P implies Q, that is if P then Q. Then law of detachment says that if P is true, then Q can be deduced as a conclusion. A little technical, I agree with you. Let us look at an example. Suppose the statement which is given to me is if an angle A is greater than 90 degrees, then A is an obtuse angle. Now, this statement could have been anything. Let's say it could also have been if an angle A is greater than 90 degrees, then A should be called Ravi Handa. You do not question the statement which is given to you. You take that as an assumption, you take that as a given and move on. So, but here what we are given is if an angle A is greater than 90 degree, then A is an obtuse angle. Now, the hypothesis which is stated or the first statement is A is equal to 120 degrees. That means the P part is given to me and the P part, since A is greater than 90 degrees, it is indeed true. Now, if I know that the first part, the P part is true, then the conclusion can be deduced. The conclusion which can be deduced is A is an obtuse angle, which makes this particular statement valid. Now, as I was saying that if instead of this it was then A is Ravi Handa, then my conclusion, if it was A is Ravi Handa, that would still have been valid. This is a perfect example of law of detachment. There is nothing wrong in it. So don't just go by what the common sense says or what you have learned. Just unlearn all those principles when it comes to law of detachment or law of syllogism and stuff like that. Just use what is given to you in the original conditional statement. Continuing with another idea which comes in handy in these cases, the order is very, very important. See, I have the same statement. If an angle A is greater than 90 degrees, then A is an obtuse angle. Now, I am given Q, that A is an obtuse angle. Then what can I say about A? Is A equal to 120 degrees? Is A greater than 90 degree? All these become invalid. Even if it said that even if the conclusion which was given to me was A is greater than 90 degrees, even then it would have been invalid. I know it is true, does not matter. You have to go by the law of detachment, which says if P implies Q, if P then Q, then P should be stated to give Q or for Q to be true. Continuing with this, the law of syllogism. Well, it says if P then Q or P implies Q and Q implies R, therefore P implies R. I think this will be better with examples as well. If Larry is sick, then he'll be absent. If Larry is absent, then he will miss his classwork. That means my P statement was if Larry is sick, then he'll be absent from school is Q. If Larry is absent, that is Q, which implies R. So my statement or therefore the deduction from law of syllogism would be P implies R. That is, if Larry is sick, then he will miss his classwork. This becomes a perfectly valid statement. Another one, if Larry is sick, then he'll be absent from school. If Larry is sick, then he will miss his classwork. Again, you can look at it in terms of P and Q. So let's say this is P implies Q. This one is P implies R. Now you don't know what is the relationship between Q and R. What is this statement saying? If Larry is absent, so that means this statement is saying Q implies R. What can you say about Q implies R? There is no relationship between Q and R from this. And that is why we will mark this as an invalid statement. So once again, what you need to know, what you need to remember, what you need to use is if P implies Q and Q implies R, then you can deduce P implies R. Now, questions on this, as you can see, will not be this simple. They'll be a little complicated than this. Let us look at some of the questions which have been asked on law of syllogism and similar topics in the past. Well, this is my one example. Statement 1 is, if Joe buys Nancy a card, he'll give it to her. Statement 2 is, if Nancy is having a birthday, then Joe will buy her a card. Which of the following conclusions are valid? And then 4 conclusions are given to you. Now, if you go through them, all of them seem more or less similar, all of them seem correct, but you don't have to solve it that way. What you need to do is solve it mathematically, or rather solve it logically. Mark these statements as P, Q and R. Joe buys Nancy a card. That is my statement P. He will give it to her. That means Joe gives Nancy a card. That is my statement Q. Nancy having a birthday is the third part. So let me call it R. Now, what does statement 1 say? Statement 1 says, if Joe buys Nancy a card, that is P, he will give it to her. That is Q. So statement 1 is P implies Q. How about statement 2? If Nancy is having a birthday, that is R, then Joe will buy her a card, that is P. So statement 2 becomes R implies P. Now how can you combine these two? Well, you have P implies Q, but you do not have a Q implies anything. So you can't combine it that way. But you can combine it the other way around. You have R implies P and you have P implies Q. How can you combine these two? You remove the P from here and here. What will you be left with? You'll be left with R implies Q, and that is your conclusion. So what is R implies Q in terms of words? R is Nancy is having a birthday and Q is Joe gives Nancy a card. So if Nancy is having a birthday, that is R implies Q, then Joe will give her a card. So this becomes my valid conclusion. Which statement is this? If Nancy is having a birthday, then Joe will give her a card is statement A. And that, my friends, is the answer that you were looking for. Just to clarify, I know it's a simple idea, but it's always better to take more examples. Just to clarify the same idea, let us look at one more example. Once again, this is from a previous paper. Statement 1. If triangle is right, then the measure of one of its angles is 90 degrees. Statement 2. If the sum of two angles of a triangle is 90 degree, then the triangle is right. Now once again, you should not be concerned with whether these statements are true in real life, whether you know geometry, whether you don't know geometry. All that is absolutely irrelevant. Just go by plain logic. Mark these statements as P, Q, R or whatever. So if triangle is right, so triangle being right is a part, I'm calling that P. Measure of one of its angles is 90 degrees. Okay, measure of one angle is 90 degree, I'm calling it Q. If sum of two angles of a triangle is 90, so this becomes my third one. Sum of two angles of a triangle is 90 and then the triangle is right. So again, these are the three basic key statements that I have. Now, I will convert statement 1 and statement 2 in these terms. So what is statement 1? If a triangle is right, so that is P, then measure of one of its angle is 90 degree, that is Q. So statement 1 is P implies Q. How about statement 2? If sum of two angles is 90 degree, sum of two angles of a triangle is 90, that is R. Then the triangle is right, that is P. So statement 2 is R implies P. Once again, how you can combine these two? This P goes and you are left with simply R implies Q. And if you are left with just R implies Q, what is R? Sum of two angles of a triangle is 90. So if sum of two angles of a triangle is 90, if sum of two angles of a triangle is 90, that is R implies Q, then the measure of one of its angles is 90 degrees. That is Q. So which statement do we get here? If sum of two angles of a triangle is 90, then the measure of one of its angles is 90 degree. Well, that is statement B, and that is the answer that you are looking for. With this, I'd like to wrap up this session on logical deduction. Please provide feedback via email or via Twitter. My mail ID for your reference is ravihanda@gmail.com. Thank you.